I wanted to go over some of the problems that we had talked about that were interactives or the games. One of them was this leapfrog test, and I had done this in class. And what was supposed to happen is that you were supposed to move the frogs so that they were every other. You don't want to um, move it so that you have like two green frogs together or two brown frogs together. So when you decide right here after you jump the first one, you decide, hey, what do I do with this green guy? Do I move him forward or do I move the brown guy forward? What you're going to want to do is you're going to want to move the brown guy forward. Hop the green over the brown, green over the brown, advance the green on the end, and then it's going to be hopping of the brown, hopping of the brown, hopping of the brown, and we keep going in that fashion until you get to the end. So that's how you did the leapfrog question. The other one was the tower problem, which I have already practiced, and it says after you get to 4 discs, after you figure out that pattern, then it lets you move a big stack at one time. So right now I have done 5, and it's going to let me move 6. Or I'm sorry, it will let me move 5 at a time. So once you get to that point, you grab those 5, move your disc over, etc. So what the important part is to figure out what this pattern is. And if you notice at the bottom of the screen here, it's counting the number of discs for me. And so that's what I want to investigate further. So basically what I want to look at are the number of discs compared to the moves that we've got. Let's kind of park my tools over here. Okay, so we said that if we had, say, 1 disc, then there only is going to be 1 move, and I think they gave that one to you. You didn't have to figure that one out. If you had 2 discs, it took 3 moves to move all of the discs in such a manner that you only put a smaller one on top of a larger one. You can't put a larger on top of a smaller. Then I had 7 moves for 3 discs. When I had 4, I had 15 moves. When it was 5 discs, it took 31. And when it was 6, it took 63. 7 it took 127, and then 8 I didn't do. So what we want to do is we want to decide what the pattern is. And this one is not arithmetic, right? I'm not adding something to each one of these every time. However, you might notice, let's see, that it's almost geometric. Because if you look at the difference that you have here, you've got, or I'm sorry, yeah, the difference, it's 2, and then it's 4, and then it's 8, and then it is 16. So you're like, oh my gosh, that's kind of awesome. If you think about powers of 2, you know, the first power of 2, if you have 2 to the 0, it's 1. 2 to the first is 4. 2 to the third would be an 8. Let's see. Oh, 2 to the first is 2. Like Mrs. Gunkelman, hello. 2 to the first is going to be a 2. Then I would have 2 to the second, 2 to the third, 2 to the fourth is 16. 2 to the fifth is 32, etc. So I think what we have here is almost powers of 2. This guy is geometric. So if you look at the number of moves here, this is going to be 2 to the 8th minus a 1 here. So what is that, 255? So some of you probably finished that. So what we're saying is that for the nth term here, I'm going to take 2, raise it to the n power, and then subtract 1. So you can do a check on that, do a spot check, like maybe you pick the 4, 15 here, and you say, all right, if I plug in a 4 into this, do I get a true statement? And the answer should be yes. The last problem I would like to discuss is the handshake problem. Basically what we have is this. If you have one person, they have no one to shake hands with. So one person would be 0 handshakes. But if you give him a friend, okay, then you definitely, they can shake hands. So 2 people would be 1 handshake. When you get to 3 people, there's different ways of doing this. Some people drew arrows on their paper, but like connecting them. So for example, they would say, this first person shakes with the second, shakes with the third, the first and the second have already shaken, so when you get to the second, he has to shake hands with the third person. So when you're looking at 3 people, you're looking at 3 handshakes. That seems to me that it could get confusing with all of the arrows, so I'm going to just label these guys. A for Adam, maybe B for Bob, and C for Carlos. All right, so I've got my A, B, and my C. I'm going to add another guy. Okay, here he's going to be Dan. So I've got 4. So basically, what happens here? I'm going to keep track of this. Let's see. A has got to shake with B. A has got to shake with C. A has got to shake with D. Then B shakes with C, and B shakes with D. And then lastly, C and D have to shake hands. So when I have 4 people, it is 6 handshakes. Let's add another guy. We're going to add Ernie. Okay, there we go. So A still shakes with B, A still shakes with C, A still shakes with D, but now you have to add in E. So A and E are going to shake hands. Let's see, B shakes with C, B shakes with D. B also has to shake with E. Then in the next row, C and D shake, C and E have to shake. And then lastly, we have D and E. So when I have 5 people, I'm looking at 10 handshakes. Let's do one more. You might have an idea about what's going on now. So if I have F, I'm going to have to add A and F have to shake hands. B and F have to shake hands. C and F have to shake hands. D and F have to shake hands. And then lastly, E and F have to shake hands. So if you look at it, 6 people are going to have 15 handshakes. And you might consider how I just added that last row. Okay, I had 5 that I added there. The time before that, I had added 4 handshakes when I got another person. And the time before that, I had added, sorry, I thought I switched colors on you there. Before the time before that, I thought I had, or I added 3, and this might start to look familiar now. And then I had, 2 before that, and then that 1. So these actually are triangular numbers. It's off a little bit though. If you remember, the nth triangular number was given to us with that formula from Gauss, n times n plus 1 divided by 2. But for n people, I actually want the n minus 1th triangular number. Check it out. If I have, for example, the 5 people, the 5th triangular number actually is 15. So I don't want them to match up. I want it to match up with the 4th triangular number. So this guy would be the 4th triangular number here. So what I've got to do is I've got to replace my n with an n minus 1. So it looks like n minus 1 times n minus 1 plus 1. And that would all be divided by 2. And of course we can simplify that. N minus 1 times an n, all divided by 2. So I think the question that I had asked in the notes was for 30. So what you would do is plug a 30 in to that formula, and then you would have the number of handshakes.